All right, we're on page 2 of the notes. We're going to talk about arc length today. So we talked about arc measure last time, which measure is out of 360 degrees. Arc length would be like if you take a tape measure and figure out how many like inches it is from C to B. So your measurement for arc length, see over here, it's like in a measure that you are used to seeing. It's not degrees, it's like, I guess not really a ruler, but taking something that can bend and measure that. This is the definition of arc length. So like if you're given a radius, this is the formula that you were used. This is how these are related. But today we're probably going to do something a little different and move this to the other side of the equation. This is obviously something that you can use if you're just looking for arc length. But today we are going to be looking for different things. Like we may possibly be looking for the central angle. Like here you're looking for the central angle. You may be looking for the radius. Down here you're looking for the radius, or you may be looking for arc length. So in order to do this and make it a little easier on you, I'm going to give you this proportion. You guys are good at proportion, so that should be helpful. So the arc length over the circumference, 2 pi r, is equal to the central angle over 360. So we basically just took 2 pi r, which this right here is the circumference. So you may also see it as circumference at some point. Circumference. Yeah. So that's your formula. What we have, all right? So notice there's the radius, there's the arc length, there's the central angle. And so all we really did was we took this and we divided by that on both sides. Which, if you're looking for the arc length, you probably will want to use this formula. But if you're looking for the central angle or the radius, it's best to leave it like this in this proportion, then you can just cross multiply and it's easier. But for this one, find the length of AB. So AB is this arc length right here. So AB is the arc length. If you did not know that, there we go. AB is the arc length. The arc length is that thing. So we're going to put an X where the word arc length is in our formula. And then we're going to go over 2 times pi times, we know the radius, it is 12, equals, which this ends up being 24 pi, but I'm just kind of showing you where these things are coming from. Zoom that in a little bit. Hopefully you have this written down already, because I will reference it, but not leave it on the screen the whole time. The central angle is 45 over 360. All right, a few ways that you can solve this. You can start by like simplifying this 45 over 360 if you'd like, or you can just cross multiply, and that is fine too. So I think I'm just going to cross multiply, but it is always an option to simplify this ratio if you'd like. So 360x on one side. We can't really see that on here, but 45 times 2 times 12, 1080 pi. Oh, that's not what we want. 1000, I forgot the 0, 80 pi. All right, and then we're just going to solve for x. So divide by 360. It ends up equaling 3 pi, or it just depends on how it's, like, does it ask for it in terms of pi, or does it ask for it to the nearest decimal? If it does, you would obviously just multiply 3 times pi and get 9.4. Things that you might notice. There's 3 things we're looking for, so you have 3 examples on here. This one, we are looking for the angle measure. This is the central angle. Angle measure, I'm going to put in parentheses, central angle. That's what we're talking about. You can also look at the picture and see that that's the central angle. So the arc length is 12. The 2 times pi times 5 is the circumference over the central angle, which we don't know what that is, so I'm just going to call that x. And then over 360, because that is the formula. All right, that's the relationship of all of these things. And then you can, type these things in the calculator. All right, so cross multiply. We have 10 times pi times x equals 360 times 12, 4,320. And then you're going to divide by 10. Pi. Divide by 10 pi. Okay, when you divide by 10 pi, this is something that some of us struggled with on that surface area and volume test. Some of us would put this in the calculator, 4,320 divided by 10 pi, and you would get the wrong answer because what this does is divides by 10 and then multiplies by pi. Oh goodness, we don't want that. So don't do that. Either put this in parentheses or put it in this little fraction bar thing. 4,320 divided by 10 pi. And whoa, what if we get this crazy number? That's okay. You can just click math 2, enter, and it will give you the decimal. 1, 3. So I think so we're doing a Canvas assignment today, and I'm pretty sure everything it's like a decimal form because you can't type pi in on Canvas like you can on Delta Math. So this is what it's going to look like. You type this in the calculator and you get a decimal. All right, let's move on. Need is going to be x, so my radius is going to be x. I'll go ahead and write that. Radius, x. So arc length is 3.82 over 2 times pi times r, because we don't know what the radius is. We're going to write it as, well, I guess I could write it as x, but I'm going to leave it as r. But this just shows what we're looking for. Equals central angle over 360. I mean, this is a pretty easy one to go ahead and simplify this and make it 1/6 if you would like to. Just make smaller numbers, but you don't have to. You can just go ahead and multiply these out. So 2 times 60 is 120 pi times the radius equals 3.82 times 360, 1,375.2. And then we're going to divide by 120 pi on both sides, and it's pretty easy, hopefully. This, divided by 120 pi, 3.6 is going to be the radius, depending on what it wants you to round to. We'll just say 3.6. So then there's 10. All right. And that is all.